Well, good afternoon, grade 11s. And, we've been talking about the component method. And I just wanted to show you in this video just an example of how to do the component method completely on a question. I actually found this, question here in a math textbook, and that's why they use slightly different notation for the angles. And I just want to fix it so that it looks more like ours. So here you see it says north 30 degrees west. Well, what you need to do with that is take the north to convert it and move it to the end and write of in between. So it's actually 30 degrees west of north. This one here, we'll move the north to the end. It's east of north like that, 40 degrees east of north. Finally here, the south, we're going to move to the very end, and it's west of south. This is of north on the top, okay? So in other words, I'm going to write these vectors down here. Let me make it a little simpler maybe. Delta D1 is 25 meters, and it's 30 degrees west of north. Delta D2 equals 30 meters, and it is 40 degrees east of north. And delta D3 equals 35 meters, and it's 25 degrees west of south. All right. Now, what they're asking us for is to add the following displacement vectors and use the component method to do it. So that's what we're going to do. We're going to use this method. Okay, so here's a little summary of how to do that. Step one, you make a table. And part of this step is choosing what we want for positive. So let's look at the east and west. I have two wests and I have one east right there. So I'm going to go with west as positive. You can't really choose wrong. Okay. Now for north, I have two norths, but I only have one south. And so I'm going to go with north as positive. But again, you can make the opposite choice. It really doesn't matter. Okay, you can't really choose wrong here. And you'll see as we go through the method what I mean by that. All right, now part of step one is now taking each vector and breaking it into components. Now, what I taught you yesterday was that the first component after the angle always goes with sine, and after the of always goes with cos. All right, and the 25 meters here, that's your hypotenuse. So my first vector, the west component, is going to be 25 sine 30. Don't take out your calculator yet. Don't need it yet. And this one's going to be 25 cos 30. Okay. Now I do the same thing with vector number 2. Put it right underneath it. This one is going to be negative 30 cos or sine, pardon me, of 40 degrees. Now, why did I write negative? The reason why I wrote negative is because this vector is east, but we said west was positive. Since it's east, I have to make it negative, and you've got to do that, otherwise you're going to be making a mistake. Now, finally, my third vector is going to be 35 sine, oops, I forgot to put the other component, so let me do that in a moment. 35 sine of 25 for that guy. Let's go back to the second vector for a second. The north component would be 30 cos of 40. And then finally, the west component, or sorry, the south component would be negative 35. Negative because we said north was positive, but that guy is south. And we said north was positive, so it's negative 35 cos of 25. Now, can I just point something out? That looks like all the norths go with cos and all the west go with sine. That's true in this question, but it's not always true. It just depends on the order that they're worded in. So for example, if I said 30 degrees north of west, that's a valid direction, then north would go with sine instead of cos. So it just depends on the order, so you can ignore the little coincidence there. All right, so now that we have these totals here, we move to step 2. Step 2, we total up each component. So I want the total west component, and I do it just by adding these three values together. So I take out my calculator and I do it all in one shot. I go 25 times 30 sine minus 30 times 40 sine plus 35 times 25 sine. And I get 8.008. So I'm going to write 8.008. I don't want to round it too much, but that's pretty good. Okay, now let's do the same thing with the north component. So I take out my calculator. I'm going to actually store that one in memory. Now I go to my north component. I go 25 times 30 cos plus 30 times 40 cos, and then minus 35 times 25 cos equals, and I get 12.911. All right, so I've got my two components, the total north, the total west. So now these two components, I'm going to highlight them. These two components make a right angle triangle, right? There's a west component and a north component. So all I have to do to put them together, okay, is use Pythagorean theorem. So Pythagorean theorem goes like this. The total displacement, therefore, squared equals 8.008 squared plus 12.911 squared. See, that's just Pythagorean theorem. C squared, C squared equals A squared plus B squared, right? This is a right angle triangle. So putting it all together, I get that. So I'm going to square my north component plus my west component squared equals that square root. I get 15.193. So delta, after I take the square root, I get 15.193 meters. Okay. Now I also need the direction of this vector. Well, the trick for direction is tan of theta equals small over big. Okay. And the small one is the west component at 8.008. So let me write 8.008 divided by the bigger one is the 12.911, the north component. Now I'm going to note that I put west on top and north on the bottom. So my answer will be west of north. Okay, so let me make that point clear to you there, west of north. So now I'm going to just figure out what theta is. 8.008 divided by 12.911 equals that. Take the inverse tan of that. I get 31.8 degrees. So theta equals 31.8 degrees, and it's west of north. Okay, so now just to summarize everything, therefore my total displacement is, okay, 15.2 meters. I'll just round it now to 15.2, and it's 31.8 degrees west of north. Wonderful. Okay, there you have it. So that's how you do total displacement problem where you're adding three vectors. Now, if I ask for the total distance, I'm just going to say note. The total distance, you wouldn't use this method at all. You just look at your original numbers. So go back to the original numbers. You're going 25 meters, then you're going 30, then you're going 35. So the total distance would just be 25 plus 30 plus 35. And it has no direction, okay, associated with it. So it's much easier to get the total distance here. 25 plus 30 plus 35. Oh, I'm getting lazy. That's 91. No, it's not 91. It's 90, right? Yeah, 65 plus 25 is 90. So this is equal to 90 meters with no direction. It's a scalar. Distance is a scalar, right? All right. So there you go. There's a video explaining how to use the component method. I hope that makes sense to you. And I'm going to make actually a separate video explaining the next lesson, which is on relative motion. So